Right. And yeah, we can talk about it at the end of class. And then let me share my screen. Start the broadcast. All right. So let's go like this. So let me see. Greetings, gentlemen. So this is what the top of week 3, right? So, this week we wanted to focus on section 1.3. Next week, we can anticipate exam 1 to become available. I think I scheduled it to open up this upcoming Sunday at 11:11 a.m., so a little bit early. And then it's available for 7 days. It's due basically 7 days later on Sunday night at 11:59 p.m. So it's in the middle of the night, going from Sunday to Monday. We get unlimited attempts at all assignments, right? And the system is set to take our highest score. And we can work on any assignment past the due date, but there's a 10% late penalty for any questions submitted past the due date. Also, as a courtesy, I think I did do a prerequisite for this exam in that you have to pass the corresponding quizzes for the exam. So there's a quiz 1, 2, and 3 for weeks 1, 2, and 3. You have to pass those. I think each quiz is like 5 questions, so I think you got to get 4 out of the 5 correct in order to access the exam, right? So that's just a heads up. You just want to definitely make sure. And keep in mind, this is remote asynchronous. You're not obligated to stay. So once you get your attendance credit, the real intent is for this time to be like a study session or a Q&A. It's really an opportunity. It's like office hours where we meet. I just fill it with like lectures and going through the homework and stuff, just to be filling the dead air. But if you are stuck on a homework assignment or quiz, we can actually work on it together now. Same with the exam. Once that becomes available, we can kind of if you have questions, we can talk about it. That's what class time is for, right? I think that's the pertinent information. My energy is really low. It's always a struggle getting to your class and the class before you guys, just because it's the end of the day. For my students earlier, I went through as much of the lecture as I could, so their presentation was a little bit different. You all could watch either my 3 o'clock presentation or my 9 o'clock presentation. Those are the ones that are the same for you. This should be College Algebra with online lab. So in addition to our work that's on Pearson that contains our homework, quizzes, and exams, I just want to kind of remind everybody that you should also have connected with Dr. Lamar, my colleague. She's the facilitator for the lab component of our grade. We're using Alex for the lab portion. And she has the details. In order to access it, you just log into our Blackboard page, and on the left-hand panel, there's a link that says Online Alex Lab. You click on it, and within that link, you can find Dr. Lamar's contact info. You just reach out to her, and whatever it is that she tells you that you need to do, that's what I expect you to do. And then basically, she's going to give me a grade for each student that I'm going to take it and factor it into your overall grade. I think the lab counts for 10% of our overall grade. All right, so let me check. Okay. So, as usual, feel free, if you have questions, just feel free to unmute yourself, get my attention, ask your question, or you can type it in the chat, and I do check the chat periodically. So I think for you all, what I'm going to do is just start on the homework. There are 21 questions in this section. The furthest I made it today was about to question 10. So we might make it there a little bit further. And then we'll see about Wednesday. Wednesday, I will either just keep going through more of the homework, or I might backtrack and do the lecture. I just kind of change it up now because I'm my energy is real low, and I'm just trying to do something different so that we can bring a little bit of spice to it. Right. So today we want to talk about section 1.3 functions, right? And if I'm talking too fast, or we just need to go back again, you just have to get my attention so we can change the rhythm or rate, the pace, and talk about something else. So determine whether the relation is a function and give the domain and range, right? So a function, So a function is basically an equation where we take a set of input values, we pass it through our equation or our function, and it's going to generate a set of output values, right? So each input value corresponds to exactly one output value. We don't have the case where one input produces more than one output, right? So what we're seeing right now on the screen is what's called a correspondence diagram, where the left-hand circle is that set of input values. The domain here is 4, 11, and 18. And then the output values are the 20 and 10. And so these are basically like a set of ordered pairs, right? So is the relation a function? It's a function is if every x corresponds to exactly one y. We don't have one x corresponding to more than one y, right? So again, in this correspondence diagram, we have two arrows that point to the same y value. That's okay, right? I'll call that a merge. A merge in a correspondence diagram is okay. So we don't have any repeating x's. So is this relation a function? We're going to say yes and hit enter. So again, the domain is going to be our set of input values. So our inputs here are 4, 11, and 18. Let me zoom out. Four, 11, and 18. There it is. Okay. And then our range is a set of output values. Our outputs are 20 and 10. So what's the domain in this case? On the right-hand panel, our set of inputs. So we have what? Let me see the comments here. -3, -2, -1, 0, that's a 0, 0, 1, and 2. Okay. And then our range, our set of outputs, is going to be what? 0, -4, and -3, I think is all of them. Notice that we're not repeating any of these results. And I think we also have 3. So then is this a function? Again, every x needs to correspond to exactly one y. If we have any repeating x's, then it's not a function. All right, so I don't think we have any repeating x values. So is this a function? We're going to say yes. Okay. Determine whether the following equation defines y as a function of x. So for this one, we want to solve for y, right? So if we solve for y, we subtract x on both sides, we're going to have y equals -x plus 47. If you were to look at the graph, you know, like you could choose several values of x, find the corresponding y, and plot the points. This is going to make a straight diagonal line, right? If we have a diagonal line, no matter where we place a vertical line, it's only going to touch our graph once. So that means that every x corresponds to exactly one y. So then is this going to be a function? We're going to say yes. Okay. Every x corresponds to exactly one y. But in this one, right, if we want to determine whether this equation defines y as a function of x, if we go ahead and solve for y, we have y squared, right? So does anybody know how to undo the squared from y squared? Anybody know how to undo that? So in order, go ahead.
You said how to remove the squared from the y?
Yes.
You do the square root on both sides.
So if we do the square root on both sides, what symbol do we need to include?
The square root symbol?
Well, but when you take the square root, there's another symbol that we need to include. So whenever we take the square root on both sides, we also have to include plus or minus.
Oh, okay.
So because of the plus or minus, when we go to take that square root on both sides, we have to include the plus or minus. So then that means that we can find one value of x that corresponds to more than one value of y, right? Because of the plus or minus. So because of the plus or minus, does this equation define y as a function of x? We're going to say no, because we could find one x that corresponds to more than one y. Give me just a moment. Oh. Sorry about that. Okay. Let's keep going. Oh, okay, here, right? So determine whether the following equation defines y as a function of x, right? Anybody know what this graph looks like? Or have a way to describe this graph? So square root function in this form, what it is going to be the top half of a sideways parabola. So if we think about a parabola, a U-shaped curve, and we turn it to the right and then cut it in half, square root is typically the top half of a sideways parabola. So if our graph was the top half of a sideways parabola, can we find one x that corresponds to more than one y? That would be a no, right? Each x in the domain corresponds to one y in the range. So, you know, if you were looking at the graph, you had the top half of a sideways parabola. No matter where you place the vertical line, it's going to touch the graph once. So does this define y as a function of x? We're going to say yes.
I got a question.
Yes.
So like for a formula like that, can you like plug it into the calculator and like graph it and see like
yeah. Yes, there's a couple of ways, right? So for the previous one, let me see this one. You can like choose different values of x. So what would help is if you had a sense of like the domain, right? And we're going to talk about that, but we could talk about it now, right? Where the domain is the possible set of input values for this. What kind of numbers can we not take the square root of?
Like decimals, I guess.
Okay, we could take the square root of decimals, but that's close. I don't know if close is the, but so when we're doing square root, one of the main thing is if we want to say keep real numbers, we can't take the square root of negative numbers, right? Right. So for instance, like if we took the square root of 0, the square root of 0 is 0 because 0 squared is 0. Square root of 4 is 2 because 2 times 2 is 4, right? Square root of 9 is 3 because 3 squared is 9, right? But if we think about negatives, like if we took the square root of -4, the square root of -4 is not -2 because -2 times -2 is +4, right? So we can't take the square root of negatives. So in general, the domain for a square root function, the inside part, the radicand, has to be greater than or equal to 0, right? So if we set this radicand greater than or equal to 0 and solve, we would get like what, x is greater than or equal to -20. So if x were like to the left of -20, say like -21, then that's an example of a value that's not inside the domain. But when x is equal to -20, it would work here, right? We're going to revisit that. Like I feel like this example is a little bit extreme for that. But when it comes to domain, we'll take a look at it. But yeah, so one way to graph this is choose values of x. I was bringing up the domain so you can make it have a sense of where to start. You could do like -1, 0, and 1, but the far left in this case would be like -20, right? You can go all the way to the left as -20 and then start making your way to the right. But then if you go left of -20, now you're outside the domain, right? So that's kind of, I know that was like a lot. We're going to revisit that. But so again, the first way was plotting points, or you could also, like you say here, let's do a demo. It's still a little bit, but it's a little bit quirky you'll see in a moment. So this is a TI 83 Plus emulator, right? Usually the home screen is here in the upper left-hand corner. I'm gonna click on my Y equals, and that brings this up. And I'm gonna type in the square root of X plus 20, right? Now we could just hit graph, and this is like a standard window, but this isn't an appropriate window, right? That's why it's important to know the domain. A better window would be something that captures when X is negative 20. Let's do as X goes from negative 25 to 25. I think, and let's go by, we'll let the steps be in steps of 5. I'm gonna leave the Y value as is. Hit graph, right? So you still want to be able to have a sense. You want to be able to have a sense of like the domain, right? And we'll talk a little bit more about this. So you can see here, the graph of square root is typically the top half of a sideways parabola, right? But again, we had to adjust the window because we knew about the domain, and that takes a little bit of practice. It's not so obvious. So I mean, we'll explore some more ways to kind of explore these. Suppose you're working on your own and you're just drawing a blank, right? So on the left right here where it says get more help, if we click on that, so we have these tools that pop up. Between, so like I do encourage you all to work together. Hopefully you have like a group me or something where you guys are communicating. Also, it's a good idea to seek out the tutors. You can take this information and sit down with the tutors and walk through it with them. So after you've done what you could do on your own, what you can do with your classmates, and what you can do with the tutor, if it's still not sinking in, that's the best time to make use of the ask my instructor. Because the tutors, you've already paid them. If you don't use their services, it's like giving your money away. It's included in your tuition. But the following is the reason why I vouch for Pearson, the view and example. So if I click on view and example, it says it's 2 parts remaining. And basically what it does, nearly all the homework questions have like the view and example, and it gives an explanation as to the reasoning behind, these questions, right? So we have a question that's similar to ours, and it says 2 parts, so there's 2 more parts, right? It says this equation is already solved for y in terms of x, so therefore to determine whether this defines y as a function of x, substitute a few values for x in the equation to solve for y. A few values for x in the equation, and then solve for y. That's weird how they have that. Substitute a few values for x in the equation for y and solve. Long story short, they're suggesting choose several values of x and find the corresponding y. If you can find the x, if 2 or more values of y can obtain for 1 value of x, then the equation is not a function, right? So if you can find 1 value of x that has 2 different y values, it's not a function. So for any value of x, only 1 value of y results. So because of that, so therefore this equation is a function, right? So, that explanation was okay, but the main point is, their suggestion was choose several values of x and find the corresponding y. Just make sure that, you can't find one x that corresponds to more than one y. Let's try another example. Determine whether the following equation defines y as a function of x, right? So in this one, if we try to solve for y, right, subtract the x squared on both sides, we got that y squared. Did we talk about how do we get rid of that y squared? Take the what on both sides? Square root. And then because we're doing square root, what symbol do we need to include?
Plus minus.
And so because there's plus and minus, is this a function? Yes or no?
No.
No, right? Because of that plus or minus, one x is going to map to 2 different y's. So when that happens, we say that it's not a function.
So when you square root, it's always going to be not a function because you have the plus and minus.
Yeah, I mean, I feel like I can't think of if you're talking about functions, whether it's a function or not. I feel like I can't in my heart say that that's always the case. There might be there might be something, you just test it, but I would say most of the time, like at least 90% of the time, what you're saying is correct. There might be like a few outliers where there might be an exception to it. But generally speaking, like when we do an even root, like square root or fourth root or sixth root, anything like that, we have that plus or minus, then, it's not a function.
Okay.
Yeah, that's at least 90% accurate, if not higher. So we said no here, right? Okay. That was a good question. All right. So we got the plus or minus thing there. Now with this one, right? Same deal, but now instead of it being y to an even power, we have y to an odd power, right? So if we were to solve for y from here, subtract x cubed on both sides, and then to get rid of that power of 7, we take the 7th root on both sides. So before we did the square root, now we do the 7th root. So I think we just said in the last example, whenever we do an even root, we need to do plus or minus. But because we're doing an odd root here, we don't need the plus or minus, right? So whenever we do an even root, we need plus or minus. But if we're doing an odd root, we don't need the plus or minus. So because the plus or minus is not there, does this equation represent y as a function of x? We're going to say yes. Okay. That's about the best explanation I can give on that one. The main thing that you just have to be aware of, if you do an odd root, like third root, 7th root, 5th root, anything like that, you don't need the plus or minus. Yeah, and I think you're good to go there. But if you do an even root, you need it. Okay, next question. So given this function, we're asked to evaluate this function at several values of x, right? Where we have this g of 0, g of -1. So keep in mind, we're not multiplying by 0. We're not multiplying by -1. What we're saying is, given this function, we want to plug in when x is 0. We want to plug in when x is -1. We want to plug in when x is 5, right? So that's what this nomenclature means. This is like function notation. So for the first couple of examples, what I'm going to do is break out my trusty, dusty, rusty graphing calculator, right? And I'm going to go to my y equals and type in that function as I see it. Now, it takes practice to get your grouping symbols proper. I'm going to say x divided by, I'm going to do square root 1 minus x squared, okay? Because the square root has its own grouping symbols, I think we're good to go with our grouping, so we're good there. And then I want to evaluate this function at these different values of x, right? Notice that the results say type an exact answer using radicals as needed. So if we don't get an integer or an exact answer, and if we get like a weird long decimal, we might have to go back and write it out. But for right now, I'm gonna just plug these into the function that we just typed in, right? So on the calculator to the right, there's a button that says clear. To the left of that clear button is a button that says VARS, stands for variables. I'm going to click on that. I'm going to go to the right to go to Y variables, and I'm going to click on number 1 to call on the functions. And then number 1 again to call on the function that we just typed in. Thank you. Okay. So I just called on the function that we just typed. I did an open parentheses. Now we're going to plug in when x is 0. Now, before I hit enter, let's just test it out, right? So 0 squared is 0. 1 minus 0 is 1. 0 divided by 1 is 0, right? So we're anticipating that result to be 0, and we see it there. Okay. So when x is -1, right? -1 squared is +1. 1 minus 1 is 0. -1 divided by 0 is undefined, right? We cannot divide by 0. So I think for part A, we got a result of 0. Okay. For part B, we were dividing by 0, so we said that result does not exist. Okay. For part C, when x is 5, okay, So I'm just gonna plug this back in. I'm gonna hit second enter. Is it not? Oh, I'm missing a second. To call on the function that we did before, right? So then instead of it being 0, we're gonna change that to 5, and let's see what result we get. Okay, it says not a real answer, right? So let's go back and work it. Let's say quit. So if we plug in 5 for x into the x, on bottom, we're going to have 1 minus 25. That's going to be what? Negative 24. So I think earlier we said that we cannot take the square root of negative results. So because we're trying to take the square root of a negative, that's an example of something that's not a real number. Not a real number, right? So we tried the 5, we got not a real number. Okay. And then last is the 2/3. Now, when we try to do the 2/3, if we just plug it in, we get a long decimal, right? But they said the instructions say type an exact result using radicals as needed, right? So we kind of need to write this one out. Okay, sorry. There it is. So let's write this. Let's take some notes and write this one out. We just want to work on this last one. Okay. That looks decent. It's decent. Decent. Cool. Okay. Let's take this. Nope, not there. Sorry about that. I totally got knocked off. Oh, okay. Let me get the student, Brandon. Let me share my screen. Oh no. All right, let me log back in. Start the broadcast. Yes. What did I moment? Oh, attendance, right? Blackboard. Sorry, for some reason everything just got knocked off. It should be this one. This is the last one. Attendance. And this one, right? Yes. Okay. All right. So let's work through this example because this last one we kind of need to write it out. Unplug that. All right. So we want to evaluate G of 2/3, right? So first we want to replace each x with a blank parentheses. So we're going to have this 1 minus x squared inside the square root and then x on top, right? And we want to replace each x with this guy. Okay. So then we'll put a 2/3 here and a 2/3 here, right? Device is like is being, and part of it is because I have it plugged in. It just throws a tantrum. Okay, so let's see, there it is. So 2/3 squared is going to be what, 4/9. So then we're going to say 9/9 minus 4/9 square root under 2/3. Okay. So then we get 2/3 under, that's going to be what, 5/9? So 9 minus 4 is 5. So we can rewrite that denominator as the square root of 5. It's essentially the square root of 9, which is 3. So now when we have one fraction divided by another fraction, we use, anybody know what technique we use whenever we have one fraction divided by another fraction? So the technique is called keep, change, flip, right? One fraction divided by another, we do keep, change, flip. So we keep the first one as is, change division to multiplication, and we flip the second fraction. Square root of 9 is 3, and the square root of 5 persists. Then this 3 cancels this one, and we finish, I guess I'll go here, with 2 over the square root of 5. Now, normally we would rationalize, but I think for this context, we don't need to rationalize. But this is the exact answer. And there we go. That's better. We can compare this result because when we did it a moment ago, we got this long decimal. So if we do 2, hang on. I think everything 5. We should get the same decimal. Okay. So we got 2 divided by the square root of 5. This
one. The share screen ended.
Okay. Let's go here. Share screen. Start the broadcast. Okay. We're here. So what do we say? 2 divided by the square root of 5. So 2 divided by square root of 5. Okay. We got a solid 10 minutes. Let's try to take advantage of these 10 minutes. Find the domain. Okay. So when it comes to domain, for our purposes, there are 2 main scenarios there's others, but there are 2 main ones that we kind of talk about. This one is the first one that's called a rational function. In general, the domain of all rational functions is all reals except any x that makes the denominator 0. So if we have an x that makes the denominator 0, we got to throw the x out, right? So what we would do here is set the denominator equal to 0 and solve, and you should be able to get -2, right? So what we're saying is that all reals are going to work except x equals -2. So if we want everything except -2, in interval notation, that's going to show up as D, right? Part A is what? Everything to the right of -2, but that's not the whole picture. Part B is everything except -2, but the square brackets means we also include the -2, but that's not what we want, right? Square brackets means we include it. Parentheses mean we get really close to that thing, but we never actually reach it. So if we want to throw out -2, the only one that's actually correct is D. Part A and B are just half of it, and it's missing the other half. Part D has the wrong grouping symbol. Part B has the wrong grouping symbol. All right, so it should just be D. This is still a rational function, so we have to throw out any x that makes the denominator 0. If we set the denominator to 0 and solve, you're going to get x squared equals 36. So then plus or minus 6, right? So then, good catch. I think I'm done with that. So if we want everything except plus or minus 6, the way we captured is as follows. The far left is negative infinity up until -6. The 6 gets a parentheses because we don't want to include it. We say cup, it looks like this. And then we want to go from -6 to +6. Again, we don't want to include the 6, but we want everything between these numbers. I'm gonna say cup again. And then we're gonna go from 6 to infinity. So in interval notation, to capture everything except plus or minus 6, it looks like this. Time. Okay. So this brings us to like the second main type that we talk, where we have things a little bit different when it comes to domain. So with the rational functions, we said we can't divide by 0. When it comes to radical functions or radical expressions, what kind of numbers can we not take the square root of, or an even root? We cannot take the square root of what kind of numbers? We cannot take the square root of negative numbers, right? Because if we take, if we try to take the square root of a negative, we get non-real solutions. So generally speaking, whenever we're working with square roots, the radicand has to be greater than or equal to 0. In other words, the inside part, which is in this case would be the x plus 9, generally speaking, it would be the x plus 9, or that radicand has to be greater than or equal to 0. But because the square root is in the denominator, we have an extra stipulation that it can't be equal to 0 as well. So instead of x plus 9 greater than or equal to 0, we have to say x plus 9 is strictly greater than 0. We have to remove the bar. All right. So then if we subtract 9 on both sides, we get that x is strictly greater than -9. So then in interval notation, we're basically talking about everything to the right of -9. All right. If we can get our cursor to work, say it's doing that thing again. Okay, so to capture everything to the right of -9, we're going to start with the parentheses for our -9, and then off to negative infinity. Not negative, off to infinity. Let's do a few more. We gotta let's try to go for like another 6 minutes. Okay. So again, for rational functions, we cannot divide by 0. So we have to throw out any x that makes the denominator 0. So we want to set this denominator to 0 and solve. We would need to factor it, find the x-intercepts, and it should be, I should write it out, but I'm just not going to. 5 and 1, -5 and -1. I need to write it out, and I'm being totally lazy. X squared minus 6x plus 5. We need to set that to 0 and solve. So let's just go ahead and do that. X squared minus 6x plus 5. X squared. So if we're considering plus 5, we want to set it to 0 and solve. So it looks like we can jump straight to something of this form, where this is like x and x. Now, the second symbol being a plus tells us our two signs are the same. We don't know if they're both positive or both negative. This just says, hey, the two signs are the same. Then this other one tells us that the larger number is negative. So we're looking for two numbers that multiply to give us a positive 5 and add to give us a -6, 5 and 1, right? So we would say -5 and -1. So then now we would apply the 0 factor property. When we have two or more things that multiply to give us 0, we set each factor to 0 and solve. Long story short, we're going to get x equals 1 or 5. These force a 0 in the denominator. So we basically want to throw out x equal to 1 and x equal to 5. So the only one that correctly throws out x equals to 1 and x equals to 5 is D. Right? Let's try to do like 1 to 2 more. If my device is working properly. Let's do another. What question was that? 12, right? Yeah, we definitely made it further than everybody else. I knew that was going to happen. Use the vertical line test to determine if the graph is a function, right? So the vertical line test, if we can draw a vertical line and it touches the graph more than once, then it's not a function. But it doesn't look like any of these points are stacked on top of each other. They came close with the x equals 5 and x equals 6, but they're not stacked on top of each other. So
The share screen ended again.
it did it again? Man, yeah, we all are just like down for the count. Let's go like this, not that one. Share this, tag on it right here. Share the screen. Nope. This one. So again, looking at this graph, because there's no place where we can draw a vertical line and it'll touch it more than once. In other words, every x corresponds to exactly 1 y. Is the graph a function? We're going to say yes. Okay. Let's try to do at least 1 more. It says use the vertical line test to determine whether if y is a function of x in the graph, right? No matter where you draw a vertical line, it touches the graph once. So is it a function? We're going to say it is a function. Yes. Right? It passes the vertical line test. This is an example of something that does what? Fails the vertical line test. We can draw a vertical line. It'll touch our graph more than once. So that means we can find an x that corresponds to more than 1 y. Is the graph a function? We're going to say no. Okay. I didn't realize these questions got that light past where we stopped. I think that is enough for today, right? So more than likely what I'll do on Wednesday is try to do the lecture for you. I'll try to go through as much of the lecture as I can. Keep in mind the lecture is available on my YouTube. But you know, so that's kind of the long and short of that. Are there any questions before we kind of go our separate ways?
No.
Any burning questions?
Can you just you told me to remind me,
Okay.
remind you by my email? That's it.
Okay, let me is it something like that needs to be done off of YouTube? Like, is it personal?
Not really. It was about like the textbook.
Oh, okay, yeah. I think you asked like, just go ahead and say it again. What was your question about the book?
It was like because you need the textbook like code, right, to join the class, right? Because like
the access code. Did you buy?
Yeah, I bought it, but like the book got delayed because I bought it from off Amazon. So I'm still. I've been taking.
Is it too late to get a refund from that?
I have to double check today.
Because let me see. Is the book brand new that you bought?
No, it was a used one.
So, yeah, because the used books are not going to have the access code generally. So that's not going to serve you. The what you'd have to do is basically go to our because a used book, the access code is going to be used already. So what you'd have to do is go to our Blackboard page and and
get it from there.
Yeah, get it directly from the site because it comes with the digital book. So it's an instant thing. Yeah, but trying to order a book, don't do that.
Okay.
Because that's the long and short. Unless the book was new and you made sure that it came with the unused access code, then that would be different. But yeah,
I'm not sure. All right, thank you though.
Yeah, that was
I
good.
got a question.
Glad we talked about that. Yes, go ahead.
So is our work gonna be in Pearson or through a book that we got to download?
Pearson. It's
Pearson.
all linked in Blackboard. Let me see. I think I still got mine up. You should still be able to see my screen.
Yep, I can see your screen.
So let me go to our. Let me see. This one. Verify. So let's hop into Blackboard. So when we go to Blackboard and we go to our page, which is going to be this one. This is the main landing page, right? So for our lab portion, that's
I
going to be
don't see your screen anymore.
it keeps doing this. That's okay. Yeah, I don't understand why it's doing that. Let me share the screen. You just gotta let me know and I start the broadcast again. Okay. So when we land in the Blackboard, it looks like this. All right. One thing to bring to everyone's attention over here on the left where it says Online Alex Lab, that's where you go for the lab portion. There's two different parts. So the lab here is run by Dr. Lamar, right? So you just go through these documents to find her contact info, and then she'll give you all the details on what you need to do for the lab. Now, if we go back to our landing page, which is course content, it looks like this. For our stuff, as far as Pearson, to access it, we open up this link here, the folder. We go to folder number 4 that says assignments. So we click on that folder number 4, and you get these links. The main one that you need is the first one that says all assignments. When you click on that all assignments link, you're going to be prompted for payment. I think it runs just under $120 to get full access. But that's where our assignments are for homework, quizzes, and exams. Everything is going to be done in that first link. Once you gain full access, you also get an e-text multimedia library. So you get a digital copy of the book. Yeah, right.
So if you buy that, you don't need to get a book.
You don't need the
So
hard
you
copy.
go where it says e-text about the book?
Say that again.
You go where it says Pearson e-text buy the book?
No. You just click on all assignments, the first link.
Okay.
And it's going to come with the rest of that stuff. Yeah, the rest of it's just going to come with it. But when you click on all assignments, you'll be prompted to payment. And then once you successfully gotten in, then it'll look like this. So these are our assignments, right? So there's another link to my YouTube channel where my lectures are for these corresponding topics. And then you have these assignments with the corresponding due dates, right? So we're in week 3. This 1.3 is due this upcoming Sunday, right? So we've already 1.1 and 1.2, those were due already. Again, you can still go back and work on those and get 90% on those. You can get up to 90% on the old stuff, but you want to try to gain access and go ahead and get started. This is how we're doing our management, our assignments. And notice, right? Again, we're in week 3, right? And then it jumps to week 5 because, again, in week 4, exam 1 becomes available. And in order to access exam 1, you have to pass the quizzes for weeks 1, 2, and 3. You have to get at least a 70 in order to take the exam. Okay. So once you've gotten full access, it'll look like this. And then full access also gives you a digital copy of the book, multimedia library, like a whole bunch of stuff. Okay. These are good questions. I'm glad we're having this conversation now than not at all. Any other questions before we go our separate ways? Going once, going twice. Forever hold your peas and rice. Okay. So I'm glad we were able to kind of, again, just touch on, we have a lab portion. Dr. Lamar is going to give me a grade for each student, and I'm going to use that to factor into your overall grade. The online Alex counts as 10% of your grade. And then we're using Pearson, which we just did a walkthrough today on how to access the assignments. That's the main thing is Pearson and the online Alex Lab. Those are the main parts. If there aren't any other burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Okay, guys, take care. I'll see you Wednesday, same time, same place. Peace.
Have a good day, sir.
You as well.